Okay, we're going to finish this worksheet here. It's not a worksheet, but it's my study notes for 9.5 by talking about and exploring the idea of initial condition. Now, I know you guys have already done this with separable differential equations, so this is nothing very new. Basically, once you find your solution, and remember, we're talking about it's got to be some sort of family of functions because you got that unknown c there. If you change the c, you get a different set of functions as you wander through. In our particular case, I decided to give us y of 2 is equal to -1, which means you're going to find 1, 2, -1. You're going to find the curve, maybe it's this one right there. You're going to find the unique curve in the family of functions that satisfy not only the differential equation, but also the initial condition. So what do? Just like before, you plug in y, it says x is 2, y is -1. -1 for y, 2 for x, and we try to figure out what c has to be. Okay? All right. And it's pretty routine. It's -1 minus radical 2 is c over radical 2. Therefore, minus radical 2 minus 2 is c. And we found them. So we take our equation, y equals the square root of x plus c, and replace c with minus radical 2 minus 2 all over radical x, and call it a day. Okay? So that's the unique solution. That's this guy. Okay? The particular guy. This would be fun on Desmos to plot a few and then show yours. Really educational to use Mathematica and things like that to see the graphs themselves. But that really happens in another class on differential equations. You have an instructor that says, I want you to do these kinds of graphs, and you really learn a lot that way. But anyway, we found the unique solution. That's what this is. Unique solution. All right, now it's your turn. This is the one this is the solution of the other one we found, the second problem we did on the previous video. And your initial condition is right there. When x is 1, y equals 3, what does that force c to be? Pause. Go ahead and do it. Well, you caught me. I was sneaking in here doing it. Okay. You should. Pretty quick, isn't it? Very quick in this case. We get 3 is equal to 1 times ln of 1 is 0 plus c. That really just says that c has to be 3. See how quick that was? So you're not done. You write your answer. Y is equal to x squared paren natural log absolute of x plus 3. Thank you very much. And that's, again, the unique solution. That's all, but not really. I thought we'd do some crazy one that I picked from the homework. So just to see it from start to finish, and this one is not, it's not for the faint of heart, but let's do it anyway. It's not going to be horrible. So we look at it, it's not at all in the form we want, which is y prime plus f of x, y is equal to g of x. But we use a little shenanigans to get it in that form. Actually, the problem, I see a problem here too. I know that that guy's not supposed to be there next to dy dx. Let's work on it. So we have x squared plus 1 times y prime, thank you, plus 3xy, okay, and then this guy's special. You got extra guy here, minus 3x is 0. Okay, we're getting there. X squared plus 1 y prime plus 3xy is equal to 3x. Terrific. I remember what to do next. You divide by the x squared plus 1 all the way across, right? All right, so our problem now becomes this. We've got y prime plus, look at this thing, 3x over x squared plus 1 times y is equal to 3x over x squared plus 1. It is time for the integrating factor, e to the integral of 3x over x squared plus 1 dx. Well, guess what? You got to do a u substitution. And that's going to lead to an answer of, I believe, e to the 3/2 integral 1 over u du All right, so e to the 3/2 natural log of x squared plus 1. I don't need absolute value on it. No y, no y, no y. It's always positive. And therefore, this guy's going to come in as a power 3/2, and e and ln are going to cancel, and you're going to get an answer that is, I'll say it as I of x, which is your integrating factor, is x squared plus 1 to the 3/2 power. And that's what you multiply through with. Where? Here. So we're going to put it here times y prime plus put it here times 3x over x squared plus 1 times y, and put it here 3x over x squared plus 1. What are we putting there? The integrating factor, which is x squared plus 1 to the 3/2 power, x squared plus 1, etc. Really a how-to, huh? On the left-hand side, if we clean this up, let's see what we got. I'm only doing this. If I were in a hurry as a student, I would actually jump to a couple steps down. But what I'm doing right now is I'm verifying to you guys that we have the right answer. We've got 3x here, x squared plus 1 to the 1/2 power. And on this side, we've got 3x, x squared plus 1 once again to the 1/2 power, okay? And this has a y in it. Okay, but what I'm doing every time I do that, I'm showing you, hey man, that's the product rule. Here's this guy, and here's his derivative over here. This is this guy's derivative. So on the left, it is the product rule, derivative of the integrating factor times y. Both of those terms get gobbled up into a derivative statement. And on the right is the right. And if you're looking ahead, you're thinking, I'm going to have to integrate that. You're right. We have to integrate and integrate. Cancel. That one's easy, of course. That's what's supposed to happen. All that work that we've done so far gets us here. That's beautiful because we're now integrating out of this mess. In this case, it looks like we have to use u equals x squared plus 1 again. You know what happens, don't you? You get 1/2 du equals x dx. So you get a 1/2. So you're getting a 3/2 integral u to the 1/2 power du. Keep working. A lot of stuff here, huh? This is going to be 3/2. Now this is going to be u to the 3/2 over 3/2 plus c. That guy's going to cancel. So we've got x squared plus 1, 3/2 power times y. And we've got x squared plus 1 to the 3/2 power plus c. Beautiful. Let's divide them away. Here's our general solution. It's 1, believe it or not, just 1, dividing both sides by that parentheses with a 3/2 power. Okay, just thinking that in my head. We got y is equal to, let me write, let's get this in that color. Y is equal to 1 plus c over x squared plus 1 to the 3/2 power. We have an initial condition, y of 0 equals 2. So y of 0 equals 2 means when x is 0, y is 2. So let's put in 2 and 1 for y and x equals 1 plus c over 1 squared. 1 squared, oh boy. Plus 1 to the 3/2 power. Interesting. 2 is equal to 1 plus c over, well, that's 2, isn't it? I got a different answer. Did I do that right? Oh, I'm plugging in 0. What am I doing? That's right. I must be losing it. This is 0 squared. So all of that really is just c, isn't it? So we get c is equal to 1. And therefore, our answer is y is equal to 1. I'm looking right here at the general, and I'm plugging c in, plus 1 over x squared plus 1 to the 3/2 power. That's the unique solution to this. There you go. That's the end of that video. And that's the end of 9.5, except for any questions you might have on this. Okay? See you on the next one.